Hello and welcome to part 2 of step 15. So we've kind of been building as we've, done 14, we started 15. 14, we started talking about angles of triangles as well as different types of triangles. In our last video, we started talking about what makes two polygons congruent, and kind of building up our reasoning as to how we can connect different parts that are congruent. In this step, we're going to kind of connect congruent polygons, specifically congruent triangles, back into our proof format. So if you remember long ago in step 5, we learned a whole bunch of properties and different definitions of things that we can use to show that things are congruent to each other. So we're going to now revisit that, remind you of some things here in step 15, because step 16, we're going to learn some shortcuts for showing that two triangles are congruent to each other. Okay, so one new property that we have to go over first before we can start with our proofs. I know you're excited and chomping at the bit to start them again, is this third angles theorem. Okay, so the third angles theorem says that if we have proven that two angles of a triangle are the same, then the third has to be the same. Okay, so for example, we have this cute little diagram here. So let's say, for example, C and K are congruent to each other. Okay, that's one set. And let's say that C and K are both, I don't know, let's say 40 degrees. And we've also shown that B and J are the same. So remember, this is the second set we're matching up. Let's say B and J are both 60. If we already know that information, we establish it because maybe it was given to us or maybe it was labeled in some way. We already know from step 14 in ABC, if we've already used up 60 and 40, right, that would be 100. That means that angle A has to be 80, right? And the same thing for this other triangle. If we've already used up 60 and 40, that's 100, which means that 80 has to go with L. So that means that angle A and angle L have to be congruent to each other. Okay? The name really kind of gives it away too. If it's the third angle you're proving, you've already proven the other two, then the third set has to be congruent. Okay, no matter what. Okay, so let's take a look at our first proof. So, couple things, if you remember. This is called a two-column proof because it has two columns, very imaginative in the name. Our statements are always on the left-hand side. Our reasons are always on the right. So if it's asking you to create a proof from scratch, you will have to create your little T-chart and label those as statements and reasons. Okay, those have to be labeled. The first thing that you always want to check for is your given. Okay, I just want to preface too for a second that on the state test for geometry, you will not have to create a proof from scratch. All of the proofs will either be like most of it filled in and it's asking you for one reason and it's a multiple choice, or sometimes it has multiple blanks and it's a drag and drop. So don't be intimidated by these proofs, especially for the state test. You're not going to be asked to create one totally from scratch there. Okay, so the first thing, back to what I was saying, that we want to look for is our given. And we want to make sure that that is all listed in our proof. We usually like to list the given first. Sometimes it's not always listed first, but it all has to be listed somewhere in our proof. Okay, so we have DE is congruent to GE. That's right here in statement number 1. So we know statement number 1 is given. Okay, and also the other thing you want to check is whatever you've stated, make sure it's also labeled because that's super helpful when you're trying to make sure that you've labeled everything and you've listed everything. So let's make sure DE, okay, that has one tick mark as we can see, and GE also has one tick mark. Perfect. We also know that DF is congruent to GF. Okay, that has two, that has two, that's good. So both of those came from our given, but we have two other statements that we haven't labeled yet. That actually looks like it's coming in statement 3 is more of that given. So 1 and 3 are both given. And let's make sure D has two tick marks, G has two, D, F, E. So remember, the vertex is in the middle. D, F, E would be right here, has one. And G, F, E has one arc as well. So that everything we've been given is labeled, which is perfect. Perfect, perfect. Okay, so let's go back. So we've kind of jumped over line 2. And it says that EF is congruent to EF. So think back long ago, way back to step 5. I know some of these words have come up a few times here and there, but we really haven't used this word a ton since step 5. So if you remember, something is congruent to itself because of the reflexive property. Okay. And then we're going to label that. Notice 1 and 2 tick marks is already taken, so let's label that with 3. Since it's the same tick mark, just do it once with the 3. No need to do 6 there because you're just labeling the same thing. Okay, so now we've established that all 3 sets of sides are the same. From statements 1 and 2, we have DEGE, DFGF, and EFEF. So all 3 statements are labeled, which is great. From statement 3, we have 2 of our angles labeled. And statement 4 is saying, okay, now we can also say that DEF, so that would be right here, and GEF, that those are the same. So it's really tempting here to be like, oh, we have this segment. It's cutting E into 2 perfect angles. It's very tempting here to say angle bisector. We don't want to use angle bisector here specifically because we weren't told anything about a bisector. If we were told that E is being bisected, then absolutely we would want to use some form of an angle bisector. But for now, we can't use that because, again, it wasn't in our given. But from our little postulate up here in our third angles theorem, we've already established that 2 angles were the same, so the third set has to be the same based on our third angles theorem. Okay, and then last but not least, we are going to say that these are congruent triangles. Okay, we know that they're congruent because all 3 sets of angles have a matching corresponding congruent angle. All the sides have matching corresponding congruent sides. So the way that we know this is because we know what congruent polygons are. So we're always going to use definition of congruence at the end. Okay, in step 16, we're going to learn some shortcuts where we don't have to list all of this stuff. But for now, we have to list it all because that's how we know how to prove things are congruent. All right, let's do one more just for some good practice. Okay, so we have write a 2-column proof. Okay, we've already had our statements. I already labeled the statements and the reasons. Okay, let's make sure that all of our given is labeled and listed. So J is congruent to P, that was part 1. J and P both have an arc, that's perfect. We have JK is 1 tick mark, PM is 1. JL is 2 tick marks, PL is 2 tick marks. And then we also have this extra statement that says L bisects KM. That does not show that anything's congruent yet. In order to label something with an arc or a tick mark, we have to have a congruent sign. That does not have a congruent sign. It could lead to a congruent sign, but right now we can't label that quite yet. Okay, so let's take a look at that one actually, because that's even listed first. Maybe that's the wrong blue. It says that JLK is congruent to PLM. Oh goodness. Okay, so that actually does not help us with our segment here that's bisected. But JLK, notice we have this nice little like bow tie looking figure. We have two straight lines that cross and create an X. The two angles that we've labeled are across from each other. So these are vertical angles. Okay, so you can say vertical angles, you can say definition of vertical angles are congruent, vertical angles theorem, all of those are acceptable. The biggest thing is we're hoping for that you see that they're vertical angles. That's what's super, super important, okay? All right, next one we have LK. LK is congruent to LM. Okay, so unfortunately, this is the third side, and we don't have a third side theorem or a third segment theorem, so that's not going to work. But from our given, we know that L is bisecting KM. Okay, if L is bisecting KM, that means it's cutting it exactly in half, right? If we bisect something, we split it and cut it into two equal congruent pieces. So that means that we have a segment bisector, not an angle bisector, specifically a segment bisector, because we're bisecting a segment. So we want to say, we can say definition of segment bisector. Okay, and then we jump and say that K is congruent to M. Oh, side note about the bisector. We can use a bisector in this example because we were told something was being bisected. If we're not told that it's being bisected, no reason to use angle bisector or segment bisector. Okay, and then we have K is congruent to M. Okay, we know that because in our given we were listed one angle, in the second statement we were given another angle. So this is our third angles theorem. So your last angle is 99% of the time for now going to be third angles theorem, because usually you've already listed the other two. Okay, and then we jump down and say, okay, well now we can establish that these two triangles are congruent. And we can double check. We've listed all three sets of segments. We've listed all three angles. So we've matched up all 6 corresponding congruent parts. And we know this because we know what that word congruence means. If you want to write a longer explanation about matching up the corresponding parts or anything like that, feel free. But just stating that we know that they're congruent is A-okay with me. Okay? So just there's one. Oh, nope, there's not. Okay. So that is step 15. Okay. We're going to continue working with proofs in step 16, but in step 16, we're going to learn some shortcuts. So we're not going to have to prove all 3 angles and all 3 sides. We're just going to have to prove a few things, and then we can go ahead and stop. Okay. All right. Well, thanks for watching.